So the next type of questions are from the formula 2 power n. So if a set contains n elements, then the number of subsets is given by 2 power n. And these questions will be related to the concept of power set also, because power set is the set containing all the subsets. So in this question you are given that the number of elements in A is 2. So what is the number of elements in P of A? What is the number of elements in P of A? What is the number of elements in P of A? Let us try to analyze this. So in the question you are given that number of elements in A is equal to 2. So what is the number of subsets of A? So A contains 2 elements. So how many subsets of A are there? So by the formula it is 2 square, that is equal to 4 subsets. So you have 4 subsets to A. Now what is the number of elements in P of A? So what is P of A? Power set of A is nothing but the set containing all the subsets. And how many subsets does A have? 4. So there are 4 elements in the power set. So the number of elements in power set is nothing but the number of subsets of A. The number of elements of power set of A is nothing but 4. So now if you consider power set of A, now how many subsets does this power set of A have? Power set of A has 4 elements. So the power set of power set contains how many elements? 2 power 4 elements. That is nothing but 2 power 4 is 16. So you have to raise it to power 2 again. Now what is the number of elements of P of A? So you have once again powered this. So P of A has 16 elements. So how many subsets does this have? 2 power 16. So P of A contains 2 power 16 elements. 2 power 16 elements. So I hope you have understood this. So in the exam, what you need to remember is, so whatever the number of P's that you have to write those many 2 power 2's. And above the last 2, you have to write the number of elements in A. So if you have the number of elements in A, in the next question, if you have the number of elements in A is equal to 3. So what is n of P of A? So you should not get confused by this. So this is a very simple question. The answer is, so you see, you count the number of P's that you have. You have 5 P's. So you have to write 2 power 2 power 2 power 2 power 2 power. You have to write 5 2's. And at last you have an A also. So for the last 2, the power has to be the number of elements in A. So the answer is 2 power 2 power 2 power 2 power 2 power 3. For each P you have to write a 2, and for A at the last you have to write the number of elements in A. So this is how you solve questions of this form. So let us look at another question in this type. This question is also based on the formula 2 power n. So the question says like this: difference between the number of subsets of A and B is 56. Find n of A and n of B. It's given that n of A is greater than n of B. So in this you have 2 sets A and B. A has more number of elements, B have less number of elements according to the given information. So let us suppose A has P elements, B has Q elements. So the difference between the number of subsets of A and B is 56. So if A has P elements, the number of subsets of A is 2 power P, right? And the number of subsets of Q is 2 power Q. So according to the given information, 2 power P minus 2 power Q has to be equal to 56. Now obviously if n of A is more than n of B, that means P is greater than Q. So you have to solve 2 power P minus 2 power Q is equal to 56. You have only one equation. You are asked to find both the numbers P and Q. So from one equation, usually you won't get 2 numbers. But here you have a special case where P and Q are integers. P and Q are positive integers, right? So from that condition, maybe you can solve this equation and get both the numbers P and Q. So now P is greater than Q. So let P be equal to Q plus some number K. So if P is greater than Q, both are integers. So I can write P is equal to Q plus some number K, some natural number K. So I'll put 2 power in the place of P. Let us write Q plus K minus 2 power Q is equal to 56. This implies 2 power Q times 2 power K minus 1 is equal to 56. So what is the prime factorization of 56? So as you can see, this has 2 power something and this is an odd number. This does not have a 2 in it. So the prime factorization of 56 is know that this is 8 into 7, that is 2 cube into 7. So now obviously if these two are equal, obviously you can have only one prime factorization for a single number. So if 2 cube into 7 power 1 is same as 2 power q into some odd number. So by comparison, q has to be equal to 3 and 2 power k minus 1 has to be equal to 7. This implies 2 power k is equal to 8 and k is equal to 3. So because p and q are integers, you cannot have multiple prime factorizations. So based on that theorem, you can find both the numbers q is equal to 3 and k is equal to 3. So q is equal to 3 and p is equal to q plus k, that is 3 plus 3 is equal to 6. So these are the two numbers. N of A has to be equal to 6, N of B has to be equal to 3. So this is how you can solve the problem. So now let us go to the next type of questions. So now let us look at this question. Write the subsets of the set A, which is set containing 1, 2 and 3. A very straightforward question. So how do I do this? So we can very clearly see that A contains 3 elements. So n of A is equal to 3. So this implies number of subsets of A is equal to 2 power 3, right? 2 power n. That is equal to 8. So this set has 8 subsets and you are asked to write all the subsets of A. So let us write one after the other. Subsets of A are. So first let us start with empty set. So we know that empty set is a subset of every set. Next we write subsets containing one element. That is set containing 1, set containing 2, set containing 3. All these are subsets of the set A. So I have only 3 subsets containing one element each. Now let us go for subsets containing 2 elements. There is set containing 1, 2, set containing 2, 3, set containing 1, 3. So in this way, if you write them systematically, you will not miss any subset. So you have 3 subsets containing 2 elements each. 1, 2, 2, 3 and 1, 3. That's it. And you have one subset containing all the elements. Null set is a subset of every set and every set is a subset of itself. So these two will always be there and in between them you have to write the other subsets. So these, as you can count them, 1, 2, 3, 4, 5, 6, 7, 8. You have 8 subsets. So if you want proper subsets, so proper subset is a subset which is a subset of A but not equal to A. So if you exclude this, so number of proper subsets is equal to 2 power n minus 1. So out of all these subsets, you have to exclude itself. Then the remaining subsets are called proper subsets. You have 7 of them which excludes this. You have 1, 2, 3, 4, 5, 6, 7 proper subsets. And if you are asked to find the power set of A, Power set of A is nothing but a big set containing all these subsets. Set 1, set 2, set 3, set 1, 2, set 2, 3, set 3, 1, set 1, 2 and 3. So this is the power set of A. It contains 8 elements, that is 2 power n elements. So in the next type, so I'll ask you to express the given intervals in terms of closed or open intervals. So if x is in between 2 and 3, including 2 and 3, so what do I write x belongs to? I write that x belongs to closed 2, 3. So I use square brackets. That means closed 2, 3, that is all numbers in between 2 and 3 and including 2 and 3. And next, x is going from minus infinity to 2. So starting from the extreme minus infinity, x is going towards 2. So I write that x belongs to, so if you write this on a real number line, this looks something like this. So if you have 2 here, so x goes from minus infinity to 2. So all these numbers are okay. So how will I write this in terms of intervals? X belongs to open minus infinity, close to. So remember this, whenever you have infinities, you always use open interval. Because infinities are not a number to be closed. Whenever you write close, that means infinity exactly is also included. But infinity is not a number that can be included in the interval. So always, whenever you have infinities, we use open interval. Next, x is greater than 3. So x belongs to open 3 because 3 is not included. And it goes on till infinity, right? If x is greater than 3, from 3 it can go up to infinity. So I'll use open interval for infinity. And x belongs to R. X belongs to all real numbers. So I write x belongs to, what is the interval for all real numbers? Minus infinity to plus infinity. Right? Because real numbers span from minus infinity to plus infinity. And x belongs to R plus. So usually this R plus denotes close at 0 to infinity. That's what is usually done. So whenever you write R plus, that means you're talking about closed 0 to infinity. And if you don't want to include 0, we usually write it below. R minus except 0. That is x belongs to minus infinity, R minus, that is negative real numbers excluding 0. Minus infinity to open 0. So if you just write R plus, close 0 to infinity. If you just write R minus, minus infinity to close 0. If you write R minus excluding 0, then 0 is not included. So I hope you have understood these problems on intervals. Now let us go forward.